Example 2, find the limit at infinity. So we're going to find the limit of the function 2x minus 1 all over x plus 1 as x goes to infinity. Okay? If we tried direct substitution, we would get something really goofy, like 2 infinity minus 1 all over infinity plus 1, which doesn't really make any sense at all. Okay? I guess if you wanted to, we won't even do that. So instead what we're going to do, we're going to do something known as algebraic manipulation. So we're going to take the limit of this function and we're going to divide each one of these terms by x. Okay, if I divide every single one of these terms by x, that's essentially the same thing as multiplying through by x. Okay, and then I'm going to reduce the function. So I'll have the limit of 2 minus 1 over x all over 1 minus 1 over x as x goes to infinity. Now, if I do direct substitution, I'm going to get 2 minus 1 over infinity all over 1 minus 1 over infinity. Now, this notation, again, this is not correct, but let's take a look at this. 1 over infinity is like 1 over 100, or 1 over 1,000, or 1 over 10,000, or 1 over 100,000. If you notice here, these numbers here are getting smaller and smaller and smaller and closer to 0. So we can just put zeros here and there. This is actually the correct way to write this, and then this would just simplify into being 2. Okay. So in the very beginning, when we tried direct substitution, we ended up getting something really funky. Okay? If you subtract 1 from infinity, or negative 1 is kind of irrelevant compared to infinity. So we could think of this as 2 times infinity all over infinity. Okay? If you get something like this, this is known as an indeterminate form. And all that means is, from this form here, we can't really determine what the answer is. We're going to look at that more. If we look down here, this chart's going to be a chart that you're going to want to memorize. First of all, let's look at all the indeterminate forms. So if you try to evaluate the limit and you get any of these forms below here, it's indeterminate, which just means you need to use some other method to figure out what the limit is. So if you manipulate or evaluate a limit and you get 0 over 0, that's indeterminate. All that means is you can't really tell what the answer would be. If you get positive or negative infinity divided by positive or negative infinity, again, that's going to be indeterminate. If you get infinity divided by infinity, again, that's indeterminate. You can't determine what the answer would really be. If you get 0 times infinity, same thing. If you got 0 to the 0 power, same thing. If you get 1 to infinity, same thing. If you get infinity to the 0 power, same thing. Now let's look at determinate forms. Okay? If you evaluate the limit and you get 0, if you get infinity plus infinity, you can determine that that would be infinity. If you get negative infinity minus infinity, you can determine that that would be negative infinity. If you get 0 to the infinite power, you can determine that that is 0. If you get 0 to the negative infinity power, you can determine that that is infinity, because 0 to the negative infinity power would be like 1 over 0 to the infinity power, which we said that that is 0. Okay? And this would be like, this isn't really 0, it's like getting closer and closer to 0, so this would be like taking 1 and dividing it by a really small number, which would become a larger number. Alright, if you get infinity times infinity, you can conclude that that is infinity.